friends, welcome to day 15 of our exciting AI journey. Hi, I am Akshat Goyal and today we are going to learn about deep learning. So, what is deep learning and how neural networks works? That will be our discussion. And if you have any doubts, so please do put on comments. If you haven't covered any of the videos in last 14 days, please do click the link in the description and watch our playlist. If you have any doubts, just do put in comments, and also you can mail us at aicodegyan@gmail.com. And also before that, please do subscribe to our channel AI Code Gyan, hit the like button and click the bell icon so that you don't miss any day content. Thank you. So let's start. Now let us talk about deep learning. So deep learning is a subset of machine learning that uses artificial neural networks. So we can see from the diagram how machine learning is part of AI, subset of AI, and how deep learning is also a subset of machine learning, and part of deep learning is artificial neural networks, which plays the major part in deep learning. Basically, it is a science which mimics the human brain's ability to recognize patterns and learn from experience. Also, deep learning empowers AI applications like self-driving cars, voice assistants, and image recognition. So either we talk about self-driving cars, we talk about voice assistants like Siri, Alexa, or we talk about image recognition or facial recognition used in security or at the airport. It is all use of deep learning. It also has use in recommendation systems like Netflix. So there's a use of NLP there. Now let us talk about neural networks. Now let us talk about neural networks. So everyone might be knowing about neural networks, but let us talk about it. So how do neural networks work? Basically, this consists of layer of interconnected nodes or neurons. Neurons is the unit basic unit of neural networks which process information like the human brain. So basically it stores information from 0 to 1 to make sure that information transmitted in terms of, you can say, probability. So that this is called activation, and this is the probability which is stored in the neuron, and they learn through training on large data sets. So let us talk about structure. So when we talk about structure of neural networks, basically this consists of 3 layers. Input layer, we receive the raw data, images, text and numbers. Suppose we are using deep learning for image recognition, so we'll have different image sets, and that will be like input layer. And we'll have, suppose we are using for recognizing numbers, suppose 0 to 9, and we have text. So this all things, and this all things will be done in input layer. There will be hidden layer which access patterns, performance computations. So basically this is the there will be multiple layers, and at last will be output layer, so which will produce final prediction or classification. So we'll come to a conclusion, see how this, so there's a human brain neuron and there's an artificial neuron. So when we talk about neuron in our human brain, then we have dendrite and soma. So through dendrites it will receive the impulse or the message, and so myelin sheath will be like hidden layer, and axon terminus will be like output. So this which will make sure this will transmit to brain. So, and similarly when we talk about the artificial neural network, we have input layer, hidden layer and output layer. So there can be multiple hidden layers here. Now let us understand the mechanism. So talk about mechanism. So we have forward propagation. When data flows through the layers from input layer to the output layer through the hidden layer, we have activation functions which determines the neuron output. So we'll study about it more later. We will talk about loss calculation. So basically this is the compute error which is calculated between the predicted output and actual output. So basically there is the predicted output which is calculated at the end, and there will be the actual outputs. There might be some difference based on the forward propagation, and there's a back propagation, or you can say backward propagation, which is used to adjust weight using optimization. So basically based on these errors, it is trained again and again using back propagation, and error is computed again and again, and that's how this is a deep learning model is trained. And how iteration, yeah, so when we talk about iteration, so this will involve multiple iteration, process repeats until optimal performance is achieved. So neural networks might take a day, a month, or multiple months to get trained, but this is a effective process because here that cost of training is effective, and will make sure that model is in place and we have a lot of functionalities of neural networks. Now let us understand neural network using this diagram. So we can see the mechanism, like how forward propagation is done. We have inputs x1 and x2 at the input layer, and there are some weights attached to it, and later there are some this bias attached to it in the hidden layer. We have multiple hidden layer here, and at the last we'll have the output. So, and we'll have some error function here, so that based on the prediction of true values, we have a loss function which will make sure we can optimize the values, and this process is called backward propagation. And there will be multiple iterations of this process so that we achieve the optimum solution and we get the desired result. Now let us talk about the basically how the activation function is added and how we receive the input, weights are added and bias added. So we can see an example of a neuron showing the input x1 to xn. So there are n inputs and we have n number of weights, and we'll have bias b. So we have single neuron in the hidden layer here for an example. So what will be the activation function? So f is the sigmoid value or any other activation function which is added later in the hidden layer. Before that we multiply it by a weight, that is sigma I is equal to 1 to n xi into weight of I plus bias which is added in the hidden layer, and this whole expression will be added in brackets with the activation function to make sure this remains in a limit, so to make sure that this function is giving the correct output. So we'll discuss about it more in the next slide. Now let us see the example of a neural networks. So here we are going to recognize a digit 9. Suppose input digit is 9. So we have different format of digit 9 which is available. So we'll distribute the image in 28 pixel into 28 pixel box, and this will represent 784 pixels, and this 1 pixel will be equal to 1 neuron. So here 1 pixel will be represented by 1 neuron. So there will be, if you see in the input layer, there will be 784 neurons, and in the hidden layer we are taking 16 neurons each. We are taking 2 layers. First layer will have 16 neurons, second layer will have 16 neurons, and the last layer, which will be from 0 to 9, so that will have 10 neurons. So that will be output layer. So if we add the weights and bias, so suppose weights will be around 784 into 16 plus 16 into 16 plus 16 into 10. So every, so in the input layer to the first hidden layer, 784 into 16 weights will be added, and first layer to second layer, 16 to 16 will be added, 16 to 10 will be added in the last layer to the output layer. And how will be the bias? Will be 16 plus 16 plus 10. So with each neuron in the hidden layer, there will be bias to be added. So it will be like 16 plus 16 plus 10. And how will be, so how much it comes? Weights plus bias comes equal to 13,002. So basically this much amount of variables we have in this calculation. Let us see the how the function goes. Now let us see how activation function works. So we have j variables here, j number of variables here. So we will have individual values will be a01 is equal to sigma weight 00 a0 0 plus, so a0 will be the basically input, and w0 will be the weight which is added plus weight 01 a1, that will be another input, plus b0 is the bias. Similarly we have aj number of outputs which we will get. Now how deep learning is powerful? So basically automatic feature extraction is the one of the premium feature which it has. So there is no need for manual feature engineering involving all sets of pre-processing and stuff. So we can simply have inputs to the neurons, and we need to train the model. So it is highly scalable. It can process vast amounts of data. It generalizes the basically predictions. It makes more accurate predictions on new data, parallel processing. So basically it uses GPUs for faster computations. That's why we use neural networks for large amount of computations and also it is trained of large data sets. So deep learning is transforming AI in technology. Neural networks enable machines to learn from data, and the future relies heavily on deep learning investments. So basically AI is also having a big picture in the future, and also deep learning will take huge role in it. Hello friends, so today we have covered day 15 of our exciting AI journey. Today we have covered what is deep learning and how neural networks work. If you have any doubts, just put in comments and you can mail us. And first of all, please do subscribe to our channel AI Code Gyan and hit the like button and do hit the bell icon so that you don't miss any day content. And next we'll be covering what is activation functions. So today we have covered intro to activation functions. Next we'll be covering activation functions in deep. We will be studying about ReLU and sigmoid and some more activation functions. So thank you, bye bye. Let us keep learning AI together. Bye bye.